Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about another application of divide and conquer, which is nothing but binary search. Coming to the problem statement, given an array of n elements, let us say a of n, and an arbitrary value x. Binary search problem is defined as searching the index of the element x in the given array of n. If x is not present in the array, the algorithm that we are going to define returns -1. Otherwise, it returns the index of the x where that element is positioned in the given array. This can be done by dividing the array into two subarrays and by following the divide and conquer strategy. So here I am going to play a small video. What is the process of divide and conquer strategy for binary search? Let us see this video. So by seeing this video, I hope that you understand something about binary search. Now here we are going to see the difference of linear search versus binary search. The linear search is also to be called as a sequential search. Now linear search is a simple algorithm that involves iterating over every element in a collection and comparing it to the element being searched until a match is found. This algorithm is suitable for small collections and unordered data. However, for large collections, linear search can be time consuming, especially if the element being searched for is at the end of the collection. But coming to binary search is most efficient algorithm that involves dividing the collection or dividing the group of elements into half and comparing the middle element to the element being searched for. Depending upon whether the middle element is greater or less than the element being searched for, the algorithm recursively searches the left subarray or right subarray. If the search element is greater than the middle element, then definitely the middle element, the chances of presence of middle element in the array is right subarray. If the search element is less than the middle element, then the chances of presence of that search element is left subarray. So our searching process is reduced to half. in the second iteration, we are going to search either right subarray or left subarray. So every time the array is divided into, for every iteration, the array is divided into half, only one subarray can be searched till all the elements are completed. So in this way, if the element is existed, we can return the index of the element. If the element is not exist, we can go for returning a value -1, which indicates that the in presence of the element. So here you can see, here I want to search for the element 37. This is the list of given element. In case of sequential search, first it goes for comparing with 1. Since 37 is greater than 1, it is not equal to 1. It goes for comparing with 3, then with 5, then with 7. Like that, it is going to compare with all the elements, all these elements. And since it is not equal, then the comparison goes here. Since the 37 is equal to this 37, it returns the index 11. So that is, it is going to do 11, totally 37 is present in the 11th index. That is 12th element. So that is, we are doing totally 12 comparisons. But here in case of binary search, so the low index is 0 and high index is 16. We need to find the middle element, which is nothing but 8. First, we are comparing the 37 with the middle element, 23. Since this 37 is greater than 23, so the chances of existence of 37 is definitely the right subarray. So the low value becomes the next element which is present to mid value, that is 9, and the high value becomes this only 16. Again, we are going to find the mid value, that is 9 plus 16 by 2. So again, we will get the mid value as either 12 or 13. Suppose let us say it is 12. Again, it is compared with 12. Since the 37 is less than 41, again the high value is to be, that is the presence of the 37 may be in the left subarray. So high value becomes lower, that is it becomes 11. Now the low value is 9. We are going to find the middle element. Again, it becomes 31. Again, we are comparing with this element. Since it is greater, now my low value becomes 10. Now low is 10 and high is 11. 10 plus 11 by 2, which I will get 11 only. Now I am comparing with the 37. Since it is equal, the index 11 can be returned. So in this case, just we are doing 4 or 5 comparisons. But here we are doing 12 comparisons to find the element. So that's why binary search is efficient when compared to the linear search. Now, this represents the same procedure what we explained till now. Here, 31 is the key element. First, the low index is 0 and high index is 9. When I find the middle element becomes 4. Now 0 plus 9 by 2, which is nothing but 4.5. We can take the rounded value, so that is 4. Now the key element is compared with this middle element, that is 27 with the 31. That is the first comparison. Now if here in the first comparison it is not equal, so that's why my low value becomes 5 and high value becomes 9. Again, I am going to find the middle value, 6 plus 5 by 2, which becomes 7. Again, now I compare the 31 with the 35. Since 31 is less, my high becomes 6 and my low becomes again 5 only. Now I am going to find again middle value, 5 plus 6 by 2, which becomes 5 only. Now I am comparing 31 with 31. Now, since both are same, we return the index of 31, which is nothing but 5. So here we are doing the comparisons. Here one comparison, here another comparison, and here another comparison. Just 3 comparisons that we are doing here in case of binary search. If we not go for binary search, we need to do almost 6 comparisons to find them. So that's why 50% of time is reduced here. So that's why we can say that binary search is efficient when compared to the linear search. Now here, this is the iterative algorithm for binary search. So while low less than or equal to high, we are going to find the middle element. If the key element is equal to middle element, we are going to return the mid. Else, If x is less than mid, we are going to make high as mid minus 1. Otherwise, we are making low as mid plus 1. If low greater than high, in that case, we need to return minus 1. That is element not found. Here, this gives the recursive algorithm for binary search. If low greater than high, then we return minus 1. Otherwise, if low less than or equal to high, then we are going to find the mid. If it is equal to mid, then return mid. Else, if it's less than mid, then binary search of low to mid minus 1. That is, we are going to search the left subarray. If it is, if this case is also wrong, then we are going to search for the right subarray, which is nothing but mid plus 1 to high. Right. So these two are the algorithms that what we use for binary search. Now we are coming to the time complexity of binary search. The time complexity of binary search recurrence relation can be represented as T of n is equal to C when n is equal to 1, and that is equal to T of n by 2 plus C when n is greater than 1. When solving this recurrence relation, we will get the time complexity of binary search as big of log n. So I hope that you all understood this binary search procedure. Thank you for listening. Thank you.